Now let us learn how a compiler handles array or manage array. So what are the issues that it has to deal with? So for explaining that, I will take an example of simple variable, that is scalar variable. See, in our programs, we use variables as names for representing some data. But when compiler converts into machine code will not have variable names. During execution for this variable, let us say 2 bytes of memory is allocated and the addresses are 100 and 101. Suppose during execution this is the memory allocated. This variable x represents this address and the value 10 has to be stored at that location, means at this address 100. So basically machine code should refer the location with their addresses, not by name. Then compiler has to convert name into an address. When the address can be known, when the memory is allocated. When the memory is allocated during execution. So it means the memory for the variable is allocated at execution, then only the address can be known. Then the how compiler will write down the address at compile time. So that's what we will learn about this issue in array, that is a vector variable. Here we have an example array which is already initialized in my program. Then during execution time, memory will be allocated for the array and the values will be stored in corresponding locations. Assume that these are the addresses. Now in my program, if I have written, I want to access a of 3 and there I want to store the value 10. So it means I want to store the value 10 here. Then this statement in my program has to be converted into machine code, which is referring to this address, that is 206. The address is 206. So compiler has to refer to that location, that is 206. So how this code of our program will get converted into machine code? So actually compiler needs address of a location a of 3. So how it is obtained? So at compile time the address cannot be known. So compiler will write down a formula for obtaining the address. So how that formula looks like, let us see. See, this is the name of an array and this is the first address of an array. So this first address we can call it as L0 or location 0. And the name of an array is called as base address of an array. So any location in an array, index in an array can be accessed with the help of base address. Let us say L0. So L0 is the base address, that is 200. So this is the starting address of an array. Then which index I want to access? This one. Its address is how much? 6. So this address I want to access, that is 3 into 2. This gives me 206. So why 3? This is the index that I want to access. Then why 2? Because each integer takes 2 bytes. 2 bytes. So it means from the base address of an array, location 0, I want to access a third index where each index takes 2 bytes. So the final address will be 206. So using this formula, the address 206 can be obtained. So I will convert that into a formula. This is L0 plus 3 into size of an integer. So address of a of 3 is obtained like this. Now for address of any location a of I, how it can be obtained? L0 plus I into index into. Now this is an example of integer array, so 2 bytes. If it is float array, it may be 4 byte, character array may be 1 byte, double array it may be 8 byte. So depending on the data type, the number of bytes taken by each element may vary. So I have to take the size of the data type. So we use a variable that is W. So this is base address, this is index, and this is size of data type. So this is the formula used by compiler for converting any index to an address. Now for obtaining the actual address during runtime, our program must know the base address of an array. So base address of an array will be updated once the program starts running and once the memory for array is allocated. So the address of this location is known during runtime and it is updated at runtime, and it is called as data binding. So if you want to study about this one, you can study about systems programming or assembly language programming. There you can learn about these things. So here we have learned how a compiler generates the formula. So this is a formula for address, and this is not actual address. So this is a logical address. And this is not a direct address. This is related to base address. So this is also a relative address. So the formula is a relative formula based on base address of an array. Some compilers allow declaration of an array from starting index 1 also. Then how the formula will change? Let us look at it. I have modified the declaration. Suppose in some XYZ language, an array can have indices starting from 1 to 5. Then this will be index 1 and the last index will be 5. Now, if I want to access any location in an array, that is A of 3, this location I want to modify it to 10, then how the formula is written by a compiler. So for the address of a location A of 3, the base address, that is 200, plus, see, third index is this one, so it has to reach here, that is 204. So it should be 3 minus 1, 1 less, because the indices are starting from 1 onwards, into 2. So this will be 204. So for any index, address can be obtained by A of I is, this is location 0, L0, and this is index I minus 1 into, this is the word size, that is the data type size, that is a W. So this is the formula if the indices are starting from 1 onwards. So this is not there in C, C++, but this used to be there in old languages. They used to allow array declaration from any starting index. So programmer can have an array start from 0 also, 1 also. But in C, C++, it is strictly from 0 only. A reason why? Why in C, C++ we cannot have array indices starting from 1 onwards? Let us see this. We have seen the formula for array indexes starting from 0 also. So just I will recall that formula, that was I into W. And this is index starting from 1 onwards. So this is the formula. So the difference is there is one arithmetic operation extra, that is minus 1 is extra. So if you count the number of operations, 1, 2, 3, and here there are only 2 operations. So one operation is extra. So as this is an array, for accessing each location, I have to use the formula. So if there are n location, then this operation will be performed for n times if I am accessing all the locations. So though it's a matter of a single operation, that is just one operation extra, but it will be slower depending on the size of an array. If the size is very large and I am accessing all the elements, then it will be really slow. It will be affecting the time taken by a program. That is the reason C, C++ languages, they allow array indices starting from 0 only, because the formula have just less number of operations and it is faster than this formula. So that's all about single dimension array. Now we will learn about two-dimensional array.